Alright, hi guys. Today we're going to be talking about the periodic table, where it came from, and then how we got to the modern periodic table that we know today. Okay, first thing I'm going to show you is this picture right here. Now, what this is a picture of is, there was a guy by the name of Dmitry Mendeleev. He was a Russian chemist, and this was back in the 1860s. And there was a bunch of other chemists that had this idea that elements should be grouped according to their masses. And well, what Dmitry Mendeleev did is he created this table. And that's what you're looking at right here. And what he did is he put these elements in a row. So if you can see my little red pointer, I'm going down in this row. And as we went down in this row, they got heavier. Then what he did is he noticed that there was this repeating pattern. Of, let's say, beryllium right here. It's Be. It's got the 9 next to it. And then magnesium. So if we put all of these in one really big long line, okay, with beryllium right here, and as we went across, we'd get to, boron, carbon, nitrogen, oxygen, fluorine, magnesium. Well, what he noticed was magnesium had similar properties to beryllium. So he put it below. And then we kept going over, right, all of these. And then once we get to this side, well, we notice that, once again, it's got a repeating property, so it's going to go below. So we got this chart where we can see that, yes, we're getting bigger as we go down, but more importantly, we're repeating. Okay, we see this repeating pattern, which we call periodic. And that's actually where we're going to get our definition of the periodic table from, okay, is that there is a repeating pattern on there. So, guys, let's go ahead and make sure that you get that definition written down. Okay, which is just that. Periodic, which is a repeating pattern. Then, what we saw is that there's this periodic law, okay, and that's that the physical and chemical properties, there we go. Okay, the physical and chemical properties of the elements are periodic functions of their atomic numbers. Now, when we're looking kind of back at this guy, we did it by the masses. Well, they began to understand that their atomic numbers, and this was by a guy of Moseley, Henry Moseley. He was an English chemist. Okay, and when he was looking at the data that Mendeleev did and a bunch of other guys kind of in the 1860s, well, he decided that it was about charge, specifically positive charge in the nucleus. And so now we started to realize that our periodic table should be based more on their atomic number and not so much as just the mass. And, well, one thing led to another, and we went from our periodic table that Mendeleev did, okay, which again, that's this picture right here, the one that I was showing you, to something that looks more like this. Now, this is just a rough outline, and I'm actually going to make it smaller again so that we can see it in a little bit, but we got to this idea of a periodic table, okay? And the periodic table, let's get a little definition, then we can talk about it a little bit more. So, what the periodic table is it's an arrangement of elements in order of their atomic numbers so that elements with similar properties fall into the same column or group. Okay, that's a really big idea. So we're taking this idea of Mendeleev had that the elements are in a repeating pattern, right? We have them all listed chronologically out, or in this case by mass, was Mendeleev. Well, when he saw a repeating pattern, he put it underneath, and we started a new row. When we see that repeating pattern again, we started another new row. And then a little bit later, we got through Moseley, where it wasn't by mass anymore, but now we're going by atomic number, okay, so the number of protons. And then we still had this idea that, well, even if our atomic numbers get bigger, we're eventually going to see that a pattern repeats itself in its properties and characteristics, so we have to start a new row. And that means that everything going up and down in a group or a column, okay, is going to have similar properties. So that's really kind of where we got to this idea of our periodic table. Well, if we take a look at that, we start to see that there are special groups on the periodic table. Okay, now what this is, guys, is this is the modern periodic table, except that we have different things highlighted. Okay, so you're going to notice that this is a column or a group. Well, remember that as we go across the row, our atomic number is getting bigger, and then so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18, so on and so forth. But that when we got to the end here, instead of just making it one really big long line, we knew that we needed to repeat, because everything in this red column right here are going to have similar properties. Now, what we actually did, because they all have similar properties, is we gave some of these columns different names. And we're going to go ahead and get those names written down. So what I want you guys to do is make a rough sketch of this. Do you need to fill in all of the individual boxes? No, but let's go ahead and get the outline of at least the periodic table and, this bottom section, and then we'll go from there. All right, so this first group, okay, column number 1, group 1, what this is these are all metals, and we actually call them the alkali metals. Get that a little bigger. Okay, now these metals, they all are soft silvery metals. There we go, alkali metals. They all react vigorously with water. They're the most reactive metals. Okay, that's just one of those properties. Now we're going to spend more time later looking at all of these properties, but for now I just want you to know that everything in the same group, everything in the same column, has the same properties. Okay, the next column on here, it is the orange ones. Those are called alkaline earth metals. Now this is the column with, it's going to have, what is in that column? That's the column with beryllium, magnesium, calcium, strontium. These are all fairly reactive metals, but they're not as reactive as the alkali metals. And when we get to electrons and electron configuration, we're going to figure out why. But again, for now, I want you to know that everything in this case, this orange column right here, has similar properties. Okay, they all have similar properties to each other. All right, so there you go. Alkaline earth metals. We'll get those there. Straighten it out. Make it a little easier. Okay. There we go. Alkaline earth metals. Okay. Next section on our periodic table is this kind of big section in the middle that's, whoops, wrong one. Big section in the middle that's white. Okay, we call those transition metals. These don't really have a special name. All these are just have general properties of metals. Okay, so like the whole idea that they are not brittle, that you can bend them, smash them into wires, smash them into sheets, and everything else like that. Okay, what we're going to do next is we're actually going to skip this yellow column, green column, light blue column, sky blue column, and we're going to get to this dark blue column right here. Reason we're skipping these other 4 columns, guys, these are where our metalloids are located, and because of that, they do have similar properties as we go up and down a group or a column, but because some are metalloids and then actually some of them are gases and non-metals and then some are metals, we're going to skip those. These are all just named by the first element at the top. So for example, we're going to have the first one is the boron group. Okay, the green one here is the carbon group. The light blue one is the nitrogen group. And then the sky blue one is the oxygen group, just named for the first ones at the top. But when we get to this dark blue one, okay, all of these are non-metals, and all of these are very, very, very reactive. Okay, these are what we call the halogens. And the halogens they are all non-metals, all right, and they are by far the most reactive non-metal. And that's just kind of one of the very characteristic properties of those things. So make sure that we know that those are the halogens. We'll get that right there. Okay, and then the last column on the top up here, okay, and these actually took a little while for us to figure out because they don't react with anything. Okay, they are completely unreactive, and that's actually why, oh, sorry guys, they're called the noble gases. Okay, nobles, like old medieval Europe European nobility. They didn't mix with anything. They didn't want to associate with anybody else. The noble gases are the exact same way. And a lot of this is going to make a lot more sense once we get to our electron configurations, because that's going to describe why these things have different properties. But again, for now, all I want you to know is that everything in the same column or same group has similar properties. Last sections we're going to talk about are the ones at the bottom. Okay, those are these right here. Those have special names. Those are what we call an F block element. Those are the lanthanides and actinide series. Okay, and what those are, guys, are those are just, a lot of those are like plutonium, uranium, and that kind of stuff. And again, all of these are just, you know, in this case, these have similar properties going across. So here is where we get the modern periodic table. We got that from this idea that there is repeating patterns as we go across and as we get bigger, both in mass and as atomic number, and that everything in the same column going up and down is going to have similar properties. All right, guys.